Greetings, seekers of knowledge. It's your host, Ronnie Coleman, here to guide you through some of the universe's most astonishing truths. We often think about what we need to survive, to thrive, to push our limits. But have you ever paused to consider the flip side? The precise point at which something beneficial becomes a one-way ticket to the cosmic recycling bin? Ever wonder how much of a thing it takes to unalive you? Like, how many atoms of arsenic does it take to turn you into a detective's next mystery? Consider polonium-210. A mere 0.1 grams is enough to end your story prematurely. And cyanide? A single minuscule drop can irrevocably alter your day. Even the very air we breathe, the oxygen that fuels our every cell, has its limits. Breathe too much pure oxygen under pressure, and you'll encounter oxygen toxicity. The universe reminds us that even life-sustaining elements can turn hostile if we disrespect their boundaries. Prepare to have your perceptions adjusted. Yeah, buddy.
Let's kick things off with a story that sounds like it's ripped from a comic book. But I assure you, it's grounded in documented reality. Imagine, if you will, an ordinary day, suddenly interrupted by an uninvited guest from the depths of the cosmos. This is the tale of Ann Hodges of Sylacauga, Alabama, in 1954. On November 30th, Mrs. Hodges was resting on her couch when a chondrite meteorite crashed through her roof and struck her on the hip. This wasn't a gentle tap. It left a significant pineapple-sized bruise. The Earth is vast, mostly covered by water or uninhabited land. For a celestial fragment to navigate our atmosphere and then specifically target a human being inside her own home, the odds are astronomical. Mrs. Hodges became an instant, albeit reluctant, celebrity. She holds the unique distinction of being the first verifiably documented case of a human being struck by an extraterrestrial object. Lightweight, baby. Or in this case, 8.5 pounds of cosmic rock.
Now let's journey back in time to an event so bizarre it challenges our understanding of reverence, justice, and sanity. This is the story of the Cadaver Synod of 897 AD. Pope Stephen II harbored serious grievances against his predecessor, Pope Formosus, who had been dead for about 7 months. He ordered Formosus's corpse to be exhumed from its tomb. The decaying body of the former pope was dressed in full papal vestments and propped up on a throne. Pope Stephen VI then proceeded to level charges against Formosus. The corpse of Pope Formosus was found guilty on all charges. His papal acts and ordinations were annulled, and his corpse was ultimately thrown into the Tiber River. Ain't nothing but a peanut compared to some of the heavy lifts in history, right?
From the hallowed halls of Rome, let's pivot to the sun-scorched plains of Western Australia in 1932 for a conflict that pits man against, well, a very large, flightless bird. This is the almost unbelievable story of the Great Emu War, a military operation where the Australian Army declared war on emus. The backdrop to this unusual conflict was the Great Depression. Ex-soldiers from World War I had been settled as farmers in Western Australia, encouraged to grow wheat. However, a massive migration of some 20,000 emus descended upon these farmlands. The farmers appealed to the government, and the Minister of Defence authorized military intervention. A contingent of soldiers armed with 2 Lewis machine guns and 10,000 rounds of ammunition was dispatched. The emus proved to be surprisingly formidable opponents, adopting guerrilla tactics. After several engagements and expending a significant amount of ammunition with very few emu casualties, the military operation was deemed a failure. Sometimes the opponent is just too lightweight, or rather, too fast and too smart.
Let's peel back the layers on a common fruit, the banana. It's yellow, convenient, and packed with potassium, and it's also radioactive. The source is potassium-40, a naturally occurring isotope. This isotope undergoes radioactive decay, releasing beta particles and gamma rays. This led to the banana equivalent dose, bed. You'd need to eat a colossal number to get radiation poisoning. The body regulates potassium levels, excreting excess. Enjoy that banana. Its radioactivity is just a whisper.
Beam me up, Scotty. It's one of the most iconic phrases in science fiction. But in 1998, scientists at Caltech took a small, yet profoundly significant step towards making a form of teleportation a reality, at least at the quantum level. They successfully teleported a photon. It's not like the Star Trek transporter, where an object or a person is physically moved from one place to another. Instead, it's about transferring that describes a quantum state from one particle to another. The process relies on a bizarre and wonderful quantum phenomenon called entanglement. When two particles become entangled, their fates are linked, no matter how far apart they are separated. In the 1998 experiment, scientists had an original photon whose quantum state they wanted to teleport. Using this information, scientists can then perform an operation on photon B that transforms it into an exact replica of the original photon. It's not about lifting heavy matter yet, but about lifting heavy concepts.
We look up at the moon, our constant celestial companion. It governs our tides, illuminates our nights, and has inspired poets and dreamers for millennia. But here's a subtle truth. The moon is slowly, almost imperceptibly, drifting away from us. Every year, the moon recedes from Earth by approximately 3.8 centimeters. This gradual distancing is a consequence of the gravitational interactions between the Earth and the moon, specifically the tidal forces. As the moon moves further away, its orbital period gets longer. Conversely, this process also causes Earth's rotation to slow down, meaning our days are gradually getting longer. Millions of years from now, the moon will appear noticeably smaller in our sky. One of the most spectacular celestial events we currently enjoy, the total solar eclipse, will become a thing of the past. Our moon isn't abandoning us overnight, but its gradual retreat is a reminder that even the most seemingly constant aspects of our universe are in a state of perpetual, dynamic evolution.
When we talk about heavy lifting, we often think in terms of kilograms or tons. But the universe has objects that redefine heavy. Neutron stars are unimaginably dense. They are the collapsed cores of massive stars, only about 20 kilometers in diameter. Yet they can be twice the mass of our sun. A teaspoon would weigh 6 billion tons. It would plummet through Earth's crust. These are the universe's ultimate heavyweights.
When you think of the coldest places in the universe, your mind probably wanders to the dark icy plains of Pluto. And while those places are indeed frigid, the current record holder for the coldest known spot in the universe isn't out there in the cosmic deep freeze. It's right here, on Earth, created in a laboratory. Scientists have managed to cool atoms to temperatures just fractions of a degree above absolute zero. Absolute zero is the theoretical lowest possible temperature, the point at which all atomic motion would cease. Using sophisticated techniques like laser cooling and magnetic trapping, researchers have achieved temperatures mere billionths of a Kelvin above absolute zero. At these ultra-cold temperatures, atoms behave in very strange and wonderful ways, exhibiting quantum phenomena. One such phenomenon is the Bose-Einstein condensate, a state of matter where atoms coalesce into a single quantum state. Achieving these temperatures is an incredible feat of engineering and physics. Earth, it turns out, is home to some pretty cool science, literally.
Water isn't unique to Earth. Hydrogen and oxygen are abundant in the universe. A colossal water vapor cloud surrounds quasar APM 08279 plus 5255, powered by a supermassive black hole in a young galaxy, the largest, most distant water reservoir ever detected. 140 trillion times more water than Earth's oceans, spread over hundreds of light years. Water was abundant even in the early cosmos. H2O exists in mind-boggling quantities in space.
We perceive ourselves and the world around us as solid. But this perception of solidity is, in many ways, an illusion, crafted by the interactions of forces at the atomic scale. The truth is, the atoms that make up everything, you, me, this planet, the stars, are almost entirely empty space. Consider the structure of an atom. At its center is a tiny, incredibly dense nucleus, containing protons and neutrons. Orbiting this nucleus, at relatively vast distances, are electrons. The solidity we experience comes from the electromagnetic forces between them. If you could somehow remove all the empty space from the atoms of every single human being on Earth, the entire human race would be compressed into a volume about the size of a sugar cube. It's a testament to the elegant and often bizarre rules of quantum mechanics that govern the microworld. Lightweight, in a very literal, spacious sense.
And there you have it, a whirlwind tour through some of the universe's most astonishing realities. From meteorites to the emptiness within atoms, the cosmos is a place of infinite wonder. It's in the grand scales and subtle details. These facts are invitations to look deeper and question further. Appreciate the intricate tapestry of reality. Every discovery adds to our collective portrait of the cosmos. The quest for knowledge is a journey without end. Smash that like button, drop a comment, and subscribe for more. Keep looking up, keep thinking big. Yeah, buddy.